Alright, so we are going to continue with part 2, where we're going to be solving quadratic properties using algebra this time. So, we have our objectives which we're going to go through, and you can see we're looking at explaining the minimum or maximum of a quadratic and identifying it as the vertex. We are going to, here I did skip past, we're going to talk about a parent function and look at all the properties of what a parent function has. We will solve for the axis of symmetry, which we just saw in the graph previously. We can identify whether the vertex has a maximum or minimum, as I said. And then we'll be able to solve to find what the vertex is. But we'll also be able to use an equation to find the y-intercept. So, let's try it out. Now, okay, so here we have the standard form of a quadratic equation, y equals ax squared plus bx plus c. And remember that a cannot be 0, and we're going to look back and I'd be able to identify the vertex. Remember, if this is facing up, then we have a lowest point, so we have a minimum. Okay, or the other option is if we have our graph facing downward, then you could see that there's actually a maximum point on your parabola. So we're going to be looking to solve for all these different parts, whether it be a vertex, or in this case we're going to be focusing first on the axis of symmetry. Okay, now we want to be able to find the axis of symmetry, which is x equals negative b over 2a. But we need to know where this comes from. And since we've gotten into the quadratic unit, we need to remember that these values come from y equals a x squared plus bx plus c. So if we can identify the coefficient in front of x, whether it's the a for the x squared or the b for the x, and we'll also identify c. But you can see for this formula, we're really only working with b and a. But down the road, we will be applying c. So, let's get started. Okay, so in our first example, we have y equals 2x squared plus 4x minus 8. If we go to the problem and we try to identify a, we have a is positive 2, b is positive 4, and we'll identify c. It's always good practice, so we can see that the value of c is 8, or actually minus 8, sorry, negative 8. Now if we're trying to find the axis of symmetry, we take x equals negative b divided by 2a, which in this case you're always going to reverse the sign of your middle value. So if we have a plus 4 up above, here you see, we're actually going to write it in this formula as minus 4 in the numerator. And then we're going to take 2 times whatever we have as the a value in front, which is the 2. So we have x equals negative 4 divided by 2 times 2. That would be x equals negative 4 over 4, and if you solve that, we get x equals negative 1. And there is our very first axis of symmetry that we solved for. Cool. Okay, so let's try another one. Okay, now keep in mind, if you do not have a value written in, the coefficient for x squared is what? 1. So just make a note, a is 1. B is negative 2. and C is negative 3. So, going back, we're going to use x equals negative b over 2 times a. Well, if we take negative b, it's going to be opposite opposite, or it's going to be positive 2. I meant negative negative, not opposite opposite. But we have 2 on top over 2 times 1. Now when we simplify this, it's just going to be x equals 2 divided by 2. And looking at that answer, we get x equals 1. Dunzo with that problem. Okay. So here we are finding the axis of symmetry. We're just trying to train ourselves and get used to working with these formulas. We're going to take it further once we return from break. So now let's take a look at number 3. We want to find the axis of symmetry for this. So we will do the same thing. We want to set up x equals negative b over 2a. Now looking at this, let's refresh. What is a? A is negative 1. Okay. B is positive 6. And C is negative 11. So we have x equals, remember it's going to be negative 6 on top over 2 times a is negative 1. So we're looking at x equals negative 6 divided by negative 2. Now these negatives cancel each other out. Looking at 6 over 2, which, how's that simplify? That's going to be x equals positive 3. There's our axis of symmetry, and you'll sometimes see me abbreviate that as A period, S period. So that's our axis of symmetry for number 3. Well, now we're going to take it a step further, and we're going to find the vertex. Remember, the vertex is the turning point where the two sides come together, and we can identify something as simple as, is the vertex a maximum or minimum based on the a value in our formula. So if we're looking at so we have a possibility that we have a maximum or minimum, but looking at the equation y equals ax squared plus bx plus c. If you are to analyze that, the fastest way you can identify if you have a maximum or minimum is if you check a. Nothing else in the equation matters. I want to know what's the value of a. If it is positive, now let's take a look, because this one says if it's negative. So it's going to be kind of backwards. If a is positive, here, let me get that back. If a is positive, then you're going to have a minimum, because it's going to be facing up. And it is kind of bizarre, but that's how it works. So that means if your a value in your problem is actually negative, then you would have a maximum. So those are two things to make a note of. It'd be good to help you with identifying. So okay, so this is let's see how easy this might be. Well, the following quadratic equation have a maximum or a minimum? As I look at this first one, I see that a is, honestly, I don't care what number it is, I just want to know, is a positive or negative? Well, here, a is actually positive. Now what that means is that we have a minimum. Gotta make sure I spell that correctly. Okay, we have a minimum. Now, if you look over to the right, you'll see, what is A? A is negative. We have -4 here, and again, I don't care about the 4. I just want to know that A is negative, and that means that do we have a maximum or a minimum? It is indeed a maximum. So remember, when you're looking at your A value, it's going to be the opposite of what you normally would think. And that's the way that you can help remember. Is it going to be max or min? So let's take a look at these next two. Looking at number 6 and number 7. Starting with number 6. Would this be a max or min? Okay, looking at the front, that appears to be positive. So that means we're going to have a minimum. Okay. But, looking at number 7, well, over here, some people might be like, wait, what's that? No. Don't forget, this has a coefficient of 1. So, since A is positive, then we have a minimum. Alright. Officially got that. So just keep a note. Just make a note that opposites are how we are going to identify the max or minimum. Okay, now for the vertex, see this part where it says h comma k. The reason why it says h comma k is because the vertex is the most important point in a parabola. It's the one where the two sides come together. And what we're going to do, first we're going to solve like we would if we're trying to find the axis of symmetry. Use x equals negative b over 2a. And then once you do that, then you just plug this back into your quadratic equation, and then we're going to solve for y. So we'll check this out. See how it works. Now for number 8, we have our equation, y equals 2x squared plus 4x minus 8. Again, remember we want to refer back to the negative b over 2a. So if we're trying to find the vertex, first we need to, and I'll just draw this one. Yeah, I'll draw it this time. And then we need to identify x equals negative b over 2a. Well, we have a is 2, b is 4, and we could say c that is negative 8. Alright, so looking at this, x equals negative 4, and that's over 2 times 2. Okay, simplifying, we get x equals negative 4 over 4, and thus x equals negative 1. Okay, now normally that would tell us just the axis of symmetry, which is absolutely correct, but we want to take it further and find the vertex. So, step 2 here. Check this out. We're going to take that equation above, and we are going to put x in the place, the value negative 1 in the place of each x. So we have y equals 2, and then now instead of x, I'm going to put negative 1 in its place. So I use parentheses because we got to square this. Then we have plus 4 parentheses, again, replace that with negative 1, and then we could put a minus 8 in the back. So this is the setup that we're looking for, and we're going to be doing this every time. Anytime you have an x to substitute into a quadratic equation, it's going to trade out your x squared variable and your x in the middle. Okay, so looking let's simplify, and this requires order of operations. First we need to apply the -1 to the second power. So -1 to the second is +1. So we have 2 times 1, or y equals just plain 2 here. Now 4 times -1 is -4, so we'll just drop that down. And then we have this -8, which is just kind of hanging out and waiting. Now as we look at this, 2 minus 4. 2 minus 4 is -2, and then if we have -2 minus 8, we get y equals -10. So, comparing the two, our vertex is supposed to be -1, -10. Now I know that the y coordinate here is a little bit big, but I assure you, as long as I haven't done anything wrong here, we should have -1, -10. Okay. But again, like I said, step 1 is about setting up your A, B, and C, specifically A and B, and then we can evaluate the axis of symmetry formula, plug that back into your original equation. Once you find your x, like we had x equals -1, we plug that back in for the place of x, so we had all of those -1s plugged in. And then remember, you need to raise your exponent first before you start multiplying. So that's why we had to get 2 times +1, since we squared that. Okay. Let's do number 9. So, again, we got to identify A, B, and C. So go ahead. We get -1 for A, B is 6, and C is -11. So, using x equals -b over 2a, we come out with x equals -6 over 2 times -1. Okay, now what we should get is, once we simplify, we have -6 over -2. Now solving that part here, ultimately for x, we get x equals +3. Again, remember the negatives cancel each other out, or they cross each other out. So yeah, x equals 3. And that's the first part. Now for step 2, don't forget, we need to plug this in. And one thing that I would highly recommend, almost I would require, you should put, after you put y equals, write the -1 out so we have that in front, and we know anytime you square something you have to take it, the leading coefficient, which is -1, and multiply. So we have -1 times 3 squared plus 6 times 3 minus 11. Okay, now simplifying this, we have y equals -1 times, again, make sure you raise your exponent first, so -1 times 9, which, here I'm just going to simplify that. That's going to be -9, and then if we have 6 times 3, it's plus 18, I'll drop that down, and then minus 11. So, we're looking at evaluating -9 plus 18 minus 11. Well, I know that 18 minus 9 is 9, so minus another 11, we would have y equals -2. Okay. And we have found what the vertex should be. The vertex is at 3, -2. Alright. Okay. On to this next one here. For number 10, we have y equals x squared minus 2x minus 3. So, as we simplify, let's see, we need to identify a, b, and c. A is 1. B is -2. And c is -3. So let's see what we get when we simplify a problem like this. Again, we're looking for the vertex. So just recall, we're going to solve for the axis of symmetry. Remember, it's -b over 2a. And one thing that I do want to reiterate, I write formulas down like crazy, and it really drills it in my mind. It helps me so that I never forget it. That's a great thing you can always do to kind of help yourself. That's a little tip that I would always recommend. So we take x equals -2, so we'll make that +2 over 2 times the a value came to be 1. So looking at x equals 2 over 2, which simplify or solves, we get x equals 1. That would be the axis of symmetry, but that's not just enough just yet. Okay, because we need to plug that in. So let's do it. Now, should anyone feel so inclined, you may, but because it's your leading coefficient is just 1, you don't need to write that in front. So I might say y equals, and then I'm going to put the x that we found, the actual x, which is 1. I'm going to put that in the place of x. So we have 1 squared minus 2 times 1 minus 3. Okay. Now I know 1 squared is 1. Always. Then if we take -2 times 1, we get -2 and -3. 1 minus 2 is -1, minus 3 is -4. So, the vertex here is, let me set that up, we have 1, -4. Alright, cool. 1, -4. Nice. Let's check this out. Okay. Now, looking at the y-intercept, we're getting to the, let's call it the, we're kind of going down the, it's, you know, a little bit easier now. So, if we're trying to find the parts that tell us about, here's a crucial element here. If you're trying to find the y-intercept, remember the y-intercept is the one where it crosses your y-axis. If you're looking, and I want you to zoom in your focus on your y equals ax squared plus bx plus c, that is where x equals 0, and really all you have to know is that y equals c, and that's going to tell you your y-intercept every time. It's the c value, the plus, well here, let me not cross it out. It's the plus c in the back of any quadratic equation. That's a fact. So let's show you what we mean. Alright, now we look at this problem and we want to know what is the y-intercept of this problem. Well, I see this c value of -8, and guess what? The y-intercept is 0, -8. What is that again? It is the y-intercept. Okay, it's always going to be shown in the back of the problem, so let's see. Alright, now for this next one, we have, again, a new equation. If we're trying to figure out what is the y-intercept, just look where? At C. Alright, and it looks like our y-intercept is at 0, -3. Please remember that your y-intercept is always going to be 0, y. anytime you're wondering, so that's why it's going to always be 0, and then whatever the c value is if you're looking at the equation. If you're not, maybe something else you have to do. But, okay. Alright, we're almost done. Let's take a look at some of these. Let's find the vertex. Well, you know that we have to find the axis of symmetry in the process of finding the vertex. So here I want to give you guys a little bit of a head start, and I'm going to quietly solve the problem. And so give it a try, and then you can check back in with me when you are ready. Okay, so far I'm going to look at, what do I have? Well, the vertex that I came up with just now, I've solved to find that your x-coordinate is 1 and the y-coordinate is -4, so the vertex is 1, -4. Now, is this a maximum or is it a minimum? We can't check the x equals 1, we can't check the y equals -4. Where do we look to find if it's a max or a min? Remember, that's going to be at the beginning of the problem, since a is positive. That tells us it's going to be a minimum. Alright, so this is a minimum. What is the axis of symmetry? We already found that, actually. I highlighted that. The axis of symmetry is x equals +1. So that's answer part 3 here. And what's the y-intercept? Well, the y-intercept, that is 0, -3. And that would be your y-intercept. Okay, so we got the axis of symmetry, the y-intercept, max or min, which came out to be a minimum here, and we have our vertex. Alright, well, I just want to wish you guys a great time, not only, well, working on the worksheet, but I wish you a wonderful break and a Merry Christmas and a Happy New Year, and I look forward to seeing you guys in a few weeks, or a couple weeks. Alright, take care. See you January 4th.